The Empirical Energy Podcast blows open the silent revolution, rewriting the rules of global energy markets. Measured, verified energy is no longer an alternative. It's becoming the gold standard. We dive deep with the producers, traders, consultants, and renegades driving this seismic shift. Step inside the raw mechanics of how verification and blockchain-fueled trading are dismantling the old systems and creating a future where alternative energy doesn't just compete, it takes over. This is the movement of reshaping energy as we know it, bold, unstoppable, and just getting started. Here is your host, Mark Smith.
Hey everybody, this is Mark Smith, the host of Empirical Energy Podcast, where we look at the intersection of energy, AI, and the blockchain. And I'm here with Zach Orlin from Connect.ai. Now, Zach is, tell a story about Zach. So he's a consultant engineer. And, when we started getting into this whole empirical measurement thing, one of the tools that our chemical engineer, Jana, who you can see on a previous episode, she said, hey, we ought to really look at this ProMax because it got this brand new feature, data exchange. And anyway, we started using that tool. And at some point, I remember ProMax themselves, BR&E, Brian Research, called and said, hey, I got this guy. You should really take a look at him. Anyway, I remember the first time I met you, Zach, and first 15 minutes, like, oh, we are so going to hire this guy.
Oh, you flatter me, Mark. Well, thank you for having me on here.
Well, tell everybody about your background and yeah.
But so I was previously with Brian Research and Engineering, the company that makes and supports ProMax process simulation software. Was there for about 10 years, have a chemical engineering background, good relationship with lots of oil and gas companies, and been with Clean Connect for about a year now. So since we're doing a lot of things in empirical energy and use ProMax to help us achieve it, it was a natural fit.
Excellent. Well, one of the tools that you're going to be showing us, I think is pretty cool. We call Luminary. It's a digital twin tool. But I remember when we first created the kind of idea behind it was we would go out, we do our monitoring thing, and we go have a physical tower and put the camera on it. And then a client may say, oh man, I wish we would have moved that tower 20 feet over. Well, moving a physical tower,
not so easy, right?
So we thought, hey, let's create a digital twin system. And then we can virtually place the camera and then put the camera on there and see what it would see, ahead of time. But as we got into, which we did, and it's great, and you'll actually going to show us a demo of this and that kind of thing. But since then, it's turned out to be a solution for a lot of things, more than just virtually placing the camera. But anyway, I'm going to go pop this in, and you can kind of show us Luminary, and we'll also put it into, some context as well, when we use this and this. So yeah, so pretend I'm a prospect. I don't know anything about Clean Connect, and but I'm looking at something that, like, wait, is that my site out there?
Yep, that it is. So you're a prospect. We've had a great discovery call. We learned that our services are a great fit. You're looking to operate more efficiently with our remote monitoring systems, detect fugitives, and alert that operations team when there are problems with equipment so they can make the decisions whether to roll a truck or not. Help them save money on these remote sites that might not be manned. So one thing that we'll do at the end of the call is we'll ask you to send over an example site that you're looking to get 24/7 eyes on. We'll have you send that latitude and longitude. And we have a software called Luminary where we'll digitally twin that facility with all the equipment. If it's a production facility like we have shown here, you have your wellheads in the middle, production separators, compressor, tanks, and a flare. And this gives us the ability to virtually place where our towers and cameras should be placed for proper coverage for detecting gases, liquid leaks, fire and smoke where it shouldn't be, and to monitor for safety concerns. So like you mentioned before, it could be very costly to install a tower and then have to move it after the fact. This gives us a great first pass at designing where these towers and cameras should be placed. So as an example, this is basically an overlay onto Google Earth. I've mapped out the wellheads in the middle, but essentially what we do is we have these assets, different equipment groups for us to add to the image. We use one that we represent for wellhead there. You can give it a label, number 6, and plop it there. And once your equipment is all laid out nicely, we have the ability to then place our tower, which I'll show you and kind of what we were able to visualize before we're even at your site. So I'm going to add a new tower that's going to host one of our Halo camera systems. You can choose what height you place it at. Typically, our towers sit about 40 to 50 feet in the air. We want our cameras to be about 10 to 15 feet above the tallest piece of equipment at your site. That's because we want a good field of view to detect for emissions.
And then do you also use like best practices, like where to place a tower, like make sure it's not close to a flare or stuff like that?
Absolutely. We want to be not too close to a flare, depending on the camera type that your company is specifically interested in. That's going to dictate whether we recommend a cooled versus an uncooled camera. An uncooled camera that's detecting for methane gas leaks specifically, we want that to be a little bit closer to the tanks. This is why this is a good first pass. We're going to work with you. Maybe you have existing comms tower infrastructure or a telephone pole that you can stick in a certain spot. These units require power. So after this first pass, we'll work closer with the operations team and decide where it needs to be. But yes, we do follow these specific rules on where it needs to be placed.
So how do you determine then, like you mentioned, a camera, right? So you said Halo. I know that's one version, or a camera. So, and you got like the full Minerva. Like, how do you determine which one is which? And when you look at it virtually, does it understand the difference between those and their capabilities?
Yes. So the way we'll do that is based on discussion with the customer. So some are dealing with sites that are very high concentration of methane, like a dry gas production facility. Typically, production facilities have high concentrations of methane. A midstream facility or refining where we need to cover a larger range of hydrocarbons and they might not be dealing with methane as much. That's where we would recommend using a cooled camera. And to answer your second question, yes, our distances and abilities of those different camera types, the cooled versus the uncooled, Minerva versus Halo, accounting for the different processing power between the two, which enables us to do more detection models between the Minerva and the Halo. And then secondly, the cooled versus the uncooled, we can adjust distances of detection with Luminary software. Yep. So I'm going to go ahead and assume that this is a site production facility producing dry gas. We're keeping our tower close to the tanks where the cut percentage of methane is a little bit lower than it would be near the other equipment groups. And we're going to mock up a Halo for this site. So I'm going to give it a label, input the model, input which side of the tower we're going to place it on, and I'm going to put it at the maximum height of the tower. And I'll add the camera. Let me flip it around so it's facing more the center of the facility. And now this gives us a really cool opportunity to investigate. One thing that's really important about this, our placement of cameras, is the distances from our device to different equipment groups. So you can see here in the top left of the image, and I'm going to maximize it so you can see full screen. This gives us the ability to look at what the representative field of view of the camera would be before even placing it out at the site. I can switch here to this distance mode, map it out to that separator at the end there, or the row, and we can see we're within our 100 meter recommended detection limit distance. So this would be a pretty solid placement here.
Nice.
Yep. The next process we'll go through is something called adding zones to the detection. Because the way our gas camera works is it's going to look at each equipment group or a zone in a field of view for increments of 2 minutes. Once it's done looking at the wellheads for a period of 2 minutes, it's then going to pan and tilt to the separators for a period of 2 minutes and keep rotating until it does a full 360 tour, which may take 10 to 20 minutes, depending on how many zones we add at an operator's facility. Easily enough, you can do so from these images here. So that looks like a good zone setup. I can save it here. And now this is representative of zone 1, where the camera will pan and start its tours. It's going to stare at these separators and this VRU compressor for a period of 2 minutes, look for any detections, and then move on towards other equipment groups. So this process of digitally twinning the operator's facility gives us a really no-risk way to start mapping out where these cameras should be placed, how many cameras should be placed, and then work with you, the operator, to figure out where is it feasible to be placed. Does our best option work for you?
So, what else can this do, right? I mean, I think there are other field of views like that you can do, like walking through or some other things like that.
And we also have a first-person view mode where you can digitally walk through your facility. So there's your wellheads, get a good look at your flare tower with your halo camera on it. You can go explore the tanks. So pretty neat feature to better investigate your equipment layout here.
Yeah, I think that would be good too, especially, over time as you display alerts and stuff, in a digital twin, to be able to walk a site and literally walk up to a piece of equipment and get that sort of viewpoint would be useful. All right. What else can this thing do?
Yeah, so that's typically what we do for operators interested in our monitoring systems, but Luminary is also very helpful for our Empirical Energy Improve Zero platform. This is where we're able to map out what we call measurers, or representing facility temperature gauges, pressure gauges, flow meters, to be able to begin the connection between those devices and Promax model inputs. So I can show you how we set those up here in a sec.
Okay.
So I'll do it for one of the separators. You'll see each block comes with a label, GPS, coordinates, but there's an option here for adding a measurer. And this is what we use as our label for some type of gauge or measurement device. So I'll click Add Measurer. We have the option to choose from a select list. So if you work with a specific vendor for flow meters, valves, combustion equipment, you can choose from that list here. Or you have the option to create one from scratch. So I'm just going to say, let's say this is a heated production separator. Maybe it's a GPU or has a line heater associated with it. So I'm just going to call this a separator 1 temperature gauge. We'll give it a type. For measuring temperature, we'll choose the thermometer. We'll just give it a model A. Don't need to choose a group yet. And we'll just give it a descriptive name to help the engineering team. So this is just the temperature gauge for separator 1. We'll hit create and add it to our list. And what this does, you'll see it here in the measure list, is once you have your site fully mocked up with all the equipment that we want to have visuals on, and all the equipment that we want to account for in a near real-time Promax model, this ability helps automate generation of an XML file where we can easily import that into a Promax model and begin the connection necessary for Promax's data exchange feature to work with your SCADA system and begin to start pulling in the actual temperature information from separator 1, for example. So our team would work through this for each of the equipment groups on the site. Wherever you have measurement, we often receive PNIDs, PFDs, and work with an operator's data team to hone in on this properly. But that's the process that we'll use to begin making that connection for the Pro Max model.
Well, I mean, as I would see this too, I know that, connecting all those devices, with their PNID, what we had to do before. In fact, I have an episode with Jana where she said, yeah, mapping out a facility took a long time, like well over 100 hours. And now, because we have this digital twin solution, we are, importing this raw data, able to read and categorize it, connect it to the right piece of equipment in the virtual twin. And now you have the basis to, connect it to Promax as well. So pretty interesting deal. So anyway, this is one of our little secret sauce things. Not so secret anymore.
Big time saver.
Yeah, big time. And we're trying to get it down to where, before it would take chemical engineering or connecting, everything together to the point where even a non-engineer can do this, right? They can map all these sites out and things like that. So
absolutely, just a few minute training on Luminary and you're able to map it out yourself. So with our help, of course. So
yeah, it's great. Well, hey, this is super cool, and to see this kind of thing and where we're going. And I, for me, the way I look at this, the whole industry is moving toward, we got these AI, Gen AI things, and then we've got tools, that are trying to marry up the physical world with the virtual world, right? Even the meta glasses, you put those on and you can see augmented reality. I mean, I could see a day where people could see augmented reality, right? You walk a site, you're wearing meta glasses, you look out, and not only you see the tank physically, but if you could overlay over some of the metadata that we have, right, you could actually see some interesting things that you couldn't see with a human eye, but overlay, the virtual information, like, oh, that's tank number 3. If methane's coming out, that's a 7% cut of methane. And yeah, I mean, it would. So anyway, looking at the future of these things, marrying up Gen AI for object identification, our camera, the digital twin, and all that stuff. Yeah,
absolutely. And you think about how some of these operators have hundreds, thousands of wells, several sites. It's difficult to physically walk through them all on a consistent basis. So doing these things virtually can really save time and help with that completely.
And that really is the big thing, right? Our audience is trying to minimize the truck rolls, right? Minimize going onto a site. And if they can see accurately what's going on in real time and then virtually walk a site, hey, no need to get in a truck, drive out there and do all that stuff, do it safely, if you're an AI control room and stuff like that. So, well, Zach, this has been great and super helpful. And I know that when you were, at BRNE and you were trying to help clients, implement like even data exchange, and seeing them struggle to now be part of a company that's designing software to make that easier and better. I mean, I don't know. What do you think about that?
It's a big change from when I was doing sales at Promax, for sure. Working with the operators who didn't even know which SCADA system they used, and it's a much more optimized process. So it's night and day. It's really impressive, the system that Clean Connect has put together to automate this type of near real time model using actual data. It's amazing.
And this is cool. I mean, for us too, because I think the big challenge is a lot of our clients previously, they were just getting stuck. I mean, it took them forever just to get one site mapped out. And then when they're thinking, how in the world am I going to do like 300 more or 500 more? And so I remember when our client Promax or Pure West said, all right, map out 300. And we're like, okay, let's put this all to the test. And it's getting better and better all the time, right? To where it'll map out, and the thought of being able to map out 100 sites in a month is now actually within reach, right? So it's exciting.
Yeah, with the automation tools we have now, and 300 sounded like a daunting number at the time, but with Luminary as an example of one tool we use for automation, it's made life a lot easier. 300 is the reality, absolutely.
Well, Zach, thanks for showing us kind of and I know we just barely skimmed the surface of all the features that it has, but I think it was a good overview of Luminary and what it could do, and just got to give people a perspective of what happens when you start marrying, AI monitoring with, digital twin and then underlying data there. And you and I both know behind the scenes, there's Gen AI we're using, machine modeling we're using, and all this data ends up on the blockchain, right? Which we're covering in other episodes. So, all right. Well, thanks again, Zach. Appreciate it.
Great. Yeah. Thanks, Mark.
The Empirical Energy Podcast requires more than a conversation. It takes action, research, and collective wisdom. If today's episode resonated with you, we'd love to hear your insights. Join the conversation and help us shape the future together. We'll be back with more stories, strategies, and real-world solutions that are making a difference for everyone. In the meantime, be sure to subscribe, rate, write a review, and share it with someone you think would benefit from it too. Thanks for listening, and we'll see you on the next episode.